For the third synthesis problem, you can see that it has more than two substituents. So we're adding one more substituent. And it says consider multiple pathways when more complicated syntheses are desired. So again, you have to know your reactions well. You have to know the order. You have to know whether your groups are ortho, meta, ortho, para, or meta directing groups. All of that has to come in now into solving this synthesis problem. So by looking at this, let's actually start determining what kind of groups are attached. So this is an alkyl group. And you know, by now, you should know that an alkyl group is orthopara, and that you cannot add this via Friedel-Crafts. You cannot add this because it will rearrange. So you can't use Friedel-Crafts alkylation. You actually have to use acylation. Leads to rearrangement, so be careful. So we need to think about how we would make this. Then once we have this, then you can start adding your next groups. And of course, you should add in the order in which they are activating. So you go from activating to deactivating. So for example, after you add the alkyl group, you should add the acyl group and then the nitro because it's the most deactivating groups. It's going to interfere with your Friedel-Crafts reaction. So let's take a look at that. So let's begin. Remember, we already discussed why you shouldn't start with the nitro group. Deactivates the ring. We already said rearrangement doesn't work, Friedel-Crafts alkylation causes rearrangement, so you can't add that. So all of these should be taken into account. So let's start then by doing the following. Start with the benzene ring. And let's start adding this as an acyl group, and then we can reduce it. So very well, in this case, you need to count basically how many carbons you have in that chain. And you have, in this case, you have 4. You have 1, 2, 3, and 4. So to produce this, you would need this right here. And AlCl3. Once we do that, we can add our group. Right there. Okay. So then we need to reduce this. And in this case, it wouldn't matter which one you use, whether you use the Wolff-Kishner or the Clemmensen reduction. I'll just use the Clemmensen reduction. Well, no need for this. And then I could make Now, I could make this right here. 1, 2, 3, and 4. 1, 2, 3, and 4. Very well. Now, we had to reduce this because then this would become ortho-para directing. This is, of course, meta directing. So it would not give us either one of these other substituents. So you should be aware of why we had to reduce. Very well. So now let's go to the next step. Then we would isolate so that we would add the second group, which is this one right here. And of course, we would use the Friedel-Crafts. Let me just make this a little bit smaller because I need more space. And here it is. Right there. I'm going to put the methyl right there. Now, you might say, well, I thought this was ortho-para, so you will yield in ortho. That's correct. There's no other way, there's no way of avoiding it. So you will get the ortho product, but we will choose to simply ignore it. We will choose to isolate it and just simply get rid of it and just focus on the para product. Yes, feel free to do that. That is acceptable. Then finally, we can add the nitro group. And the nitro group will have to add this one is the stronger activator. And it's going to direct the nitro group to the ortho. Let's clean it up a little bit here. Here's the nitro group right there. This is our final product. This order makes sense. And these are carefully designed. Each step is carefully designed. And this is how you would actually carry it out in the lab if you're doing research, is you would do one step at a time. And of course, each reaction can take a different amount of time. Very well. So what you should be doing is immerse yourself in this material and all of the reactions. You have them handy. We will do when we meet in class, we will do ones where we actually have something attached to these substituents. So be able to use NBS and the peroxide and light substitution, nucleophilic substitution, SN2 reactions. Also the ones that we've used, the reactions we've used since the beginning of this lecture. I will also introduce another reaction that we need to add an alcohol to make phenols when we meet next time. So you're going to have quite a bit of reactions. The sooner you start reviewing them and understanding them, understanding the ortho-para, meta-directing effects, then you will be in good shape. That's all.